Okay, let's go on with NMOS transistor. This is a figure of NMOS transistor. A NMOS transistor typically has 4 pins: the source pin, gate pin, drain, and body. And the typical collection for NMOS transistor in digital circuit is we usually collect source, body to ground. Then the behavior of NMOS is, if you have higher voltage on the gate than source, then there can be current flow from drain to source, and there must be voltage on drain. The voltage on drain must be higher than the voltage on source. Then there will be current flow. If the voltage on gate is smaller or equal to Vs, then the source and drain are cut off, and there can't be current flow between drain and source, even if you have voltage on drain greater than source. There can't be current flow. This is the behavior. So if you are smart, and if you treat this point as diode, and treat this point as diode, p-type, n-type diode, yes, you think, how can they collect it up? The body is connected to ground, so this diode and this diode must be reverse biased. The voltage on the P point is lower or equal to the voltage on the source and drain. So the diode here and there must be cut off. How they can collect it up and make current flow? Yes, you must wonder that. Here I will try to give you a simple explain. The key point is there. The gate, polysilicon, the silicon, we call this gate oxide, and the body. This one. This three forms a capacitor at this point. If you give high voltage at gate pin, there will be positive electron at the surface of the gate. The positive electron will attract negative electron to the surface under the gate. So even your body is p-type, there is some holes with negative electron. The voltage on the gate will attract negative electron to the surface, and this negative electron will collect source and drain up. Then this makes source and drain collected and can enable the current flow from drain to source if there is a voltage on the drain. So at this point, you can't treat this point as diode. They are capacitor. And if the voltage on the gate is lower than source, there is no positive electron here, and there is also no negative electron here. So the source and drain are cut off. They are not collected by negative electron. So at this point, you can imagine there must be a threshold. There must be enough voltage difference between gate and source that can cause enough positive electron here and attract enough negative electron here. Then let the negative electron collect the source and drain. Yes, you are right. The voltage difference between gate and source must be higher than a threshold value. We call this threshold voltage, and this value is usually around 0.5 watt and denoted as VTH. This is the minimal voltage difference to turn on the NMOS. So if we say clearly, the voltage difference on gate and source must greater or equal than VTH. At this condition, if you give a voltage on the D pin, on the drain pin, there will be current flow from drain to source. And this point, for this point, you can treat it as a diode. So when you give voltage at this point, there is no current flow from the drain to body. There is also no current from source to drain. From source to body. Okay. For this page and the previous page, you need to understand the turn on and turn off condition of NMOS transistor, and need to know the typical collection of NMOS transistor in our digital circuit. And you need to have the concept of VTH, the threshold voltage, to turn on the MOS transistor. And for P-type MOS transistor, it's just the opposite. The typical collection for the P-type transistor is we usually collect the source pin and the body pin to we usually collect the body and the source pin to VDD. And we need to have lower voltage on the gate pin. To make the device conductive. And of course, you have to. There is also a threshold voltage here, so you have to. We can say this. Yes. The voltage on the gate pin should be lower than the threshold of the voltage on the source pin. And if the condition is true, and the voltage on source is greater than the voltage on drain, there will be current flow from source to drain. If the voltage on the gate and source is nearly equal or greater than the voltage on source, the MOS is cut off. Even if you have voltage on source greater than drain, there is no current flow. Okay, this is the behavior of pMOS. As you can see in the figure, the NMOS body is p-type, while the source and drain is n-type with a plus. This plus means they are heavy doped, so the body is light doped. Okay, next section, we will talk about the switch model. We will model the NMOS and pMOS transistor as switch model to simplify it.